Okay, we're going to get more practice finding the sample spaces and simple probabilities and their complements with some procedures. So our next trial is having 2 children. So here we're going to talk about the gender of those children. So we can have boys or girls. And we're assuming that it's equally likely for someone to have a boy or a girl. So our sample space, if we're having 2 children, could be that you'd have a boy and then a girl, or a girl and then a boy, or 2 girls or 2 boys. So the event that we want to find the probability of is having 1 boy and 1 girl in either order. So we can see that there are 2 ways that can happen. So it would be 2 over the total possible number of ways would be 4. And 2 over 4 reduces to 1/2. Now, P of not A would mean not having a boy and a girl. So we could either just count, well, there are 2 ways that can happen. So again, it would be 2 over 4. Or we could take 1 minus 1/2, the probability we just found, which again would be 1/2. Okay, our next procedure is rolling a 6-sided die. So our sample space, you could get a 1, 2, 3, 4, 5, or 6. So event A is rolling a 5. So here we're saying, what's the probability that we get a 5? Now there's just one way to get a 5 out of 6 possible rolls. So that means the probability of not rolling a 5 would be 1 minus 1/6, or 5/6. Okay, our next one, we've got a much bigger sample space. So it says our procedure is rolling 2 dice. Okay, so the first one could be a 1, 2, 3, 4, 5, or 6. And the second one could also be any of those numbers. So to list out our sample space, we're going to have to list every possible combination. There's actually going to be 36 here. So we could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6, or 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, and if you count those up, there are 36 possible outcomes. So our event is rolling a 3 and then rolling a 5, so in that order. So we can see there's just one time that happens over 36. So not a 1 minus 1 over 36. Well, there are 35 other possibilities, so it would be 35 over 36. Now, you might say with this one that it's hard to keep track of exactly what all you need to write. So instead of just trying to write out all these outcomes, on the next page we're going to learn how we can use what are called tree diagrams to help us find sample spaces. So the first example we're going to look at here is just flipping 2 coins. So kind of along the top row, you're going to write what could happen the first time. So the first time flipping a coin, you could either get a head or a tail. Now, off of each of those items, you're going to draw what could happen the second time. So if we got a head, the second time we could get a head or a tail. And if we got a tail, we could also get a head or a tail. So now listing out our sample space, you kind of go down each of these branches or paths and get a sample space. So head, head. This one right here would be head, tail. And we could have tail, head, or tail, tail. Okay, so let's do one more example of using a tree diagram to help us find a sample space. So our next example is having 3 children. So we have the first child, and it's either a girl or a boy. Then off of each of those, for the second child, it could be girl or boy. And then for the third child, we go off of each of those. So now we can list out all of our sample spaces by going down the paths. So our first one would be all 3 girls. Then our next one would be girl, girl, boy. Then we would have girl, boy, girl. And then the last one starting with a girl would be girl, boy, boy. Then we'd have the ones that start with boy. So we could have boy, girl, girl, boy, girl, boy, 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 girl, and boy, boy, boy. So using a tree diagram like this is just one systematic way to make sure you can list out your whole sample space.